episode of Practically Intelligent, where we distill AI topics into practical and actionable steps for developers, product managers, and anyone interested in AI. I'm Akshay. I am a venture capitalist based in Seattle.
And I am Sinan. I am an AI entrepreneur and author based in San Francisco.
AI is moving just so incredibly fast. There are very interesting and juicy topics to dissect. And we wanted to have something where every episode was filled with something practically useful that if you're a product manager, a developer, a business analyst, potentially even a VC, you could take away something that was immediately useful for your workflow, for your product, for your investment thesis directly. So we'll cover a specific topic after covering a series of news and notes of a particular exciting development over the past week or two in AI. And then we're going to go really deep on a particular area that we think is really relevant, that is going to have a huge impact on how technology is developing. But maybe to start, Sinan, could you maybe give a brief intro about your background and your experience in the NLP space?
I'd love to. Yeah. So I have been working in machine learning for at least a decade. I got started when I was studying at Johns Hopkins. I actually started out studying pure math, ended up joining a startup. It was really fun. I really liked the scene. I really liked the just how it felt to work for a small company. So I ended up starting a company, joining YC, selling that company, taught for Johns Hopkins for a few years as well. Kind of ran the gamut on all things machine learning and AI. Wrote like 5, 6 books, working on one right now. But I guess I am an entrepreneur, an author, and an educator. I love writing, I love teaching, and I love building with machine learning and AI. Specifically, to your point, I work mostly in natural language AI. Even before GPT, BERT, transformers, I was working with RNNs, LSTMs, basic information retrieval systems, more small scale and medium to large scale systems. So, I think it's going to be a lot of fun to talk about not just this new wave of AI, but also talk about what that means for developers, VCs, non-developers, and non-VCs, who are actually going to be using this technology. So I think it's going to be a lot of diverse conversation topics here.
Yeah. And one thing I'll flag is, having known Sinan for quite some time, Sinan, I think your superpower is distilling incredibly complex and fast-changing technology into generalist principles. Sinan was actually my data science instructor, and the reason I got my start in machine learning almost close to a decade ago. And so, he just has this uncanny knack for explaining really, really complicated concepts in NLP in ways that are just incredibly digestible. Today's episode, we wanted to focus on reinforcement learning for human feedback. It's an increasingly important tool in developers and machine learning engineers' arsenal. And before that, though, we're going to cover some really groundbreaking news on the ChatGPT API. ChatGPT released new pricing for their API, but more importantly, also released new functionality and speed. Sinan, what stuck out to you about this new release, and what does it mean for people building on top of ChatGPT?
Yeah, I think it's what stuck out is the same thing that stuck out to most developers who kind of saw the bold face, 10 times cheaper, right, per token. I think that's what really got a lot of developers' attention. And speculation started running. Why is it 10 times cheaper? Is it because conversations are going to require multiple API calls? Is it because competition's heating up? And it's probably yes and yes, right? When OpenAI or an equivalent AI company launches a new API, platform, UI, whatever, they have to start thinking about developer relations. How are developers going to perceive this? How are non-developers going to use this platform, if at all, if it's not an API? And what are our competitors doing? And, on the topic of reinforcement learning from human feedback, RLHF, they are also concerned with what other competitors are doing that are not RLHF, but trying to achieve the same goal of alignment. So we're really in a young era of this kind of proprietary platform-based AI. I think we saw an attempt to platformatize AI in that last auto ML craze, which was 5 to 10 years ago, let's say. There was this craze of auto ML, right? You saw SageMaker, you saw Google's version, you saw all these companies who said, we'll do the AI for you. But it was not just natural language, it was all kinds of machine learning. And that took off a little bit, but it never really became this craze where everyone just loved auto ML. Like, people still hired full-time machine learning engineers. But now with GPT, with Claude, Anthropic's version, with Cohere, you're starting to see a shift away from, we need these full-time machine learning engineers to build our thing. Even with auto ML, they still got to make it work right. But now we're seeing the shift for developers who have little training in machine learning can actually generate machine learning applications much faster with a higher velocity. And I think that's awesome, frankly. I think for me, it's exciting because as someone who loves to see people building with new technologies, that's kind of the whole point. Also, it obviously opens up, proprietary versus open source, security and privacy concerns, all of which we should be diving into, today and in future episodes. But it's really a shift in how people are working in machine learning. Not just a shift in how the machine learning actually functions, which is also true, but there's kind of two tracks to talk about: is how is the machine learning different, and how are the platforms built, the ecosystems built around the machine learning models going to be different, which will change the way companies think about implementing AI machine learning. All that is changing, frankly, and to your point, rapidly.
The cost improvements, one thing that, Sinan, might be helpful is there's this denominator of tokens. But in many ways, for a lot of developers, that's kind of amorphous because you may prompt, you may change the specific domain knowledges. How should we think about cost and this 95%, cost reduction in terms of actual measurable units? What does that mean when the cost went down 95%?
Yeah. So the idea of a token is analogous in chemistry to like I'm going to get my chemistry wrong probably here, and we'll get comments on it. That's fine. But it's like this one of the smallest unbreakable units of a molecule would be like a particle, right? So it's the smallest unit of natural language processing, which you might think is a word. And a lot of people will use those terms interchangeably, which is technically wrong. But the idea is when you break down a sentence or phrase, paragraph, email, PDF, whatever, you're trying to find what is the smallest unit of comprehension for a machine. And for NLP, that usually ends up being a token, which could be a whole word, but it could be also a part of a word. But it ends up just being characters. And obviously in different languages, tokens look a little different. The general conversion on average is one word equals about 3 tokens on average in English. So the word the is usually 1 token. But for example, not a lot of AIs who know my name, Sinan. They probably don't know your name either. Sorry. They probably don't know our names as indivisible units of language. They'll instead break up our names into parts. Sin, in my case, sin, and on. AN. So those two tokens will make up my name, Sinan. So it's just basically how a machine breaks down both known and unknown words into smaller units to be able to understand them. Again, analogous to chemistry, where you say, well, I don't know this new molecule, but if I break it down into its components, I can at least gain some understanding of it without knowing what it is, off the shelf. So that's so when we think about a 10% or 10 times cheaper reduction in cost, what they're saying is per token you are paying less money. So for those people who are talking to GPT and ChatGPT and using them, they are minding how long of an input, because every token they put in there is part of their pricing scheme. So a lot of what prompt engineers, AI engineers who are working with GPT or some equivalent technology will do is they'll say, well, what is the shortest amount of input information? Because the shorter the input, the less money we're going to end up paying. And that's always going to be a consideration. And it's going to be a consideration much more, again, as the rise of closed proprietary platforms take off, is everyone's going to be looking at that cost per token, right? You go to a grocery store, cost per ounce, or that's going to be the end unit of measurement outside of quality and performance. From a pricing standpoint, that's going to be the bottom line for a lot of people.
I think the concept of a token is important because increasing the number of tokens that one can send in a single call actually changes the latency of applications. So far, we've seen for you to do, domain specific or maybe task specific calls to ChatGPT that are just more accurate. You're going to do prompting and chaining, and now that space has increased, you can do more and send more over a single API call. So it's also going to lead to more interesting applications. One thing I heard from several folks who were building, for example, email AI generated apps and founders, were that a latency with ChatGPT was such a huge issue that they had to consider self-hosted open source models. Now, in some cases, I think you're going to start to see the cost curve come down, which will obviously make it easier to build with OpenAI, but also change the quality of applications people can build relative to cost. Something else that I think, Sinan, wasn't covered was there was a separate tweet by Sam Altman, which was that OpenAI is going to change its licensing terms to prevent newer models such as GPT-4 and GPT-5 being trained on specific data. They're going to have essentially privatized environments similar to how you have virtual private clouds for models. And so I don't think that got enough attention, but I think that's actually incredibly impactful when we talk about ecosystems and open source for proprietary. So how big of a deal is that in the grand scheme of things? Did you expect that, or do you think that this will really change how startups and enterprises build AI applications?
I think it was expected. I agree that it didn't get enough attention as it probably should have. At the same time, it's one of those things where pretty much no company and pretty much no startup will use this system, right? This is aimed at Google. This is aimed at large companies. Airbnb, for example, would be like a category of company who might want to consider that idea of, well, we can't just send our users' data to some third party. SOC 2, GDPR aside, we have rules. We can't just send certain types of data to a third party for processing, no matter what. So companies like that who are sitting on a wealth of money and data will really benefit from this and really be able to deliver results that are unique to their own domain. I think that's where that's targeted. I mean, if you that pricing alone must be unimaginable for a lot of startups. So in some ways, you're right? It's huge. It's what's going to enable a wave of features from large companies. At the same time, I, Sinan Ozdemir, will probably never have to use something like that in the very near term future, because I don't work for Airbnb. I won't have the money, frankly, to spin up my own version of this on my own data, at least for now. So I will have to turn to open source alternatives, which as a developer, I really love. I do a lot of the times recommend using open source technologies over these proprietary models. Like batch processing is a perfect example. If I'm trying to build a system that can, assign labels to 1 million whatever tweets on my back end, I can't wait, frankly, even if I have the money, I can't wait for GPT-3 to go through all of them one by one. I need something that can do this batch processing at scale. So I am going to probably turn to something open source like BERT or some BERT variant to do that task for me. So it's all about picking the right model for the right task, given compute and cost constraints. We're basically talking about any other kind of technology. It's just this is the first time we're seeing it for this particular type of technology. But at the end of the day, playbooks are pretty common here. They have a cloud deployable version. They're a managed service, and it just depends on how much of it you need and how much money you have.
I think that's a good transition point into open source versus closed source. This is kind of a recurring theme we're going to monitor and cover throughout these episodes. But maybe a good primer is there's a fantastic post by Elad Gil we will link to about the possible different futures in AI. I think that right now it's non-deterministic. There's a bunch of different players and actions that will determine how things start. But you have really two visions of the world that are starting to shape up, and it's unclear how much share each one will have. You have this oligopolistic version that's essentially the major cloud providers will ally, for example. You're seeing this AWS do this with Stability. You're seeing Microsoft do this with OpenAI, and really driving, using these models to drive compute on their underlying cloud platform and lock enterprises and developers into their core ecosystem. Very similar to the cloud days. So they're really trying to push their specific models. So you'll see GPT-3 and other models, for example, hosted by Microsoft and OpenAI, and a suite of different developer services that are trying to entice developers to stay there. On the other hand, there is this future that is not locked in, and there's a bunch of alignment, ethics, philosophical debates. For this purpose, we're just going to talk about, just functionality and where it makes sense to build products. But there's also this world, exactly like you said, Sinan, where smaller models on higher quality trained data is preferable to using one of these big services.
By a long shot.
And so I'd love for you to talk a little bit about what you're seeing. And we're seeing a lot as a VCs, a lot of companies that are thin wrappers on GPT, and a lot of noise in that. But talk to us a little bit about why maybe you think the open source future is more attractive to builders like yourselves, or open source models are more attractive.
Totally. I mean, I'm going to turn this back on you at the end, because I part of the main reason people will turn to open source is defensibility and the ability to claim defensibility to a VC, right? There's a lot of talk in accelerators about how do you build defensible products using LLMs, right? LLMs, large language models, being the family, not just GPT-3, but GPT-2, which is open source, by the way. Like, you can download all the weights for GPT-2 today. You have been able to do that for years now. So how do you build defensible products on top of company provided, organization provided foundational models, whether they're open source or closed source? Now, when you're thinking open source, I mentioned before, some tasks are just better for open source models, like at scale batch processing. Being able to do a task for 1,000 pieces of text at a time is, for now, not very scalable with the type of model that GPT-3 or even open source versions are. At the same time, if I want to build a company who part of our proprietary technology is our AI, it's difficult to just say, to your point, we're just a wrapper on top of GPT-3. you kind of lose that battle pretty quickly there, because, well, then anyone can, frankly, clone that kind of technology relatively quickly. Now, where it starts to change is if you are able to fine tune GPT-3 or an open source model with your proprietary data. And I think that's kind of where everyone expected this conversation to go, is if you have a proprietary data set that happens to model or represent some proprietary, unique environment that you are capitalizing on, you are in a better place, even if you are using a closed source foundational model like GPT-3 or ChatGPT. Even if you don't fine tune ChatGPT, which as of recording, you cannot do that for ChatGPT, you can still utilize your proprietary data with ChatGPT in such a way that will make your product, your feature, defensible, right? You can build a knowledge base of your proprietary data and just use ChatGPT as a way to access that knowledge base. So you're building on top of a ChatGPT, but ChatGPT itself is not the interesting part. ChatGPT just becomes this layer of interface behind your actual proprietary technology, which is your knowledge base, which itself could be powered by LLMs. You could use OpenAI's embeddings product, which itself doesn't get enough conversation around it. I'm writing a lot about it in my new book, but it's using that to access that knowledge base in a really quick manner. So it all comes down to, how does your platform interact with the AI? How does your data differ from other companies? And if you do choose an open source model, or even GPT-3, which can be fine-tuned, if you fine-tune it on your proprietary data, you now have something that is, deliverable to a VC and say, look, we have proprietary AI models built on our proprietary data. And as a developer, that's how I see it. But I want to turn that back on you. Like, how do you view the world of defensible companies, AI, who are using LLMs, whether it's open source or just a thin layer, to your point, on top of GPT-3? How do you think about defensibility for those kinds of claims?
Yeah, I think it's interesting because things are moving so quickly. So I think it's less of GPT-3 versus open source, because I think eventually in the next 12 to 18 months, you're going to see each of these foundation model players provide exactly what you said, which is an option to fine tune in your own environment with essentially some offer of privacy settings. So I do think that is the future we're headed towards. I think that in terms of defensibility and where this goes, what we're seeing is people might bootstrap an application off GPT-3. Why? It's incredibly easy to build. It's easier than managing and self-hosting your own infrastructure. And it's easy to get started. But certainly when you have a specific task or problem you're solving for an enterprise, or even a consumer in some case, if the task is, let's say, 80% precision, a certain good level recall, that may not be good enough. And so you're going to want a smaller model trained on your task. And so we're seeing a lot of folks that start their application, see traction, and then immediately will realize that they need to fine tune or pivot to a specific domain model. Now, there's a ton of great research that, this whole data centric AI movement, which is that really the bottleneck is highly curated data. And this is a great point that we'll address in the reinforcement learning for human feedback. But I think a lot of folks are realizing that to become defensible and actually to see quality gains in their model improvement, they're going to need specifically trained models. I also think that in terms of, there's almost this slider in my head, and it's going back and forth as these chess moves develop, of how much share does OpenAI capture versus the other cloud mega caps versus open source players. And it's really a chart. And I think there's a range of factors that can affect that. First is, how fast do latency and cost fall? Because to build some of these really interesting applications in real time and have a great user experience, latency and some of this stuff does matter. Maybe we'll see some interesting applications being built regardless, but really to unlock the full potential, the cost curve matters. The second thing is really quality, right? Will that continue to hold, right? We're seeing, incredible improvements in large language models' ability to generalize. And then finally, I think that it's actually the sleeper factor that people aren't talking about is regulation and privacy, right? When at the advent of the cloud, it took years to convince enterprises to move workloads to cloud, and we're still, only 20 to 30% adopted. And I think that it's still unclear to me, the hacker is building on ChatGPT and maybe some open source models, but if you are a machine learning leader or a CIO or CTO at some established company, and really it's become clear it's not just about having your data secure for compliance use cases, but your competitive advantage in building in this new AI world is your data. Are you comfortable, even under some guarantee from OpenAI or any cloud provider, that you would be willing to do that? There has to be some bulletproof guarantees. And I think we're going to see, as people realize, both due to new regulation that's incoming around where this data is hosted, specifically consumer data, and just generalist attitudes on competition and how fast this moves, people start to decide that open source may be more preferable. But it also, Microsoft has a ton of stuff it can add and sweeten the deal in terms of ecosystem and then their scale player. So I think we'll continue to see this evolve, but it's not clear to me yet where that pie chart sits necessarily. Certainly right now, Microsoft is in the lead. And in terms of defensibility, I think you're absolutely right. I think that people will realize their defensibility is in their data and inherently want to do open source. And it'll allow them, the question is, does that allow for business agility and for you to move faster, which was certainly a huge factor in startups moving to the cloud, was just the speed of development.
Speed of development and also uptime, right? A lot of concerns with the underlying architecture, the infrastructure, I should say, of these LLMs mean, well, if a big company like, again, I'll use Airbnb, if a big company like Airbnb wants to use a third-party AI provider, they need SLA, they need guaranteed uptime, right? They have a great machine learning team who are amazing and dedicated at launching and building ML products. So if they're going to rely on a third-party AI provider, they need to be not just quality and accuracy, and they need to be secure in their uptime and performance, right? Downtime has to be minimized, and a lot of those SLAs have to transfer over to their users. So they have to be near 100% sure that, on a random Tuesday morning, Cohere, OpenAI, whatever the platform they want to use, is not going to be down, which will then cut off AI access to all of their downstream users. So that kind of SLAs also has to port over, I imagine, for a lot of those bigger companies. Does that make sense? Do you think that's accurate? Like that's something I can't really speak to as someone who's not the CTO of a large company, but as even the CTO of a 20-person startup, which I 10-20-person startup, which I was, that mattered, right? We guaranteed SLAs for our large corporate clients. And when we hosted ML models, which we did, near 10 years ago, I relied on AWS to provide that uptime, which they did. But I had to, really convince my clients that our machine learning won't just be down randomly because we are relying on the SLAs of cloud providers. So I think that's going to be a big factor too.
I think some of that gets solved over time. Like I think actually, the same thing with, debate in the early cloud days, which is, well, we can guarantee uptime. We're not sure about this third party. I do think some of the cost curves will fall. I think that I really do think that there's this really strong attitudinal barrier to the cloud that eventually got people just got comfortable with putting their workloads in the cloud. And I'm not sure if that's the case. There's a lot of hesitancy around data that's specifically going to a model say what you will about OpenAI, but they have changed their original intent several, times, whether it's, how they're incorporated, et cetera. So I think there's going to be some pushback there. I think the other thing is on the other side is I think Microsoft's doing an excellent job, which is they're really good at ecosystems, which is I think they'll provide eventually uptime guarantee. They'll provide a good enough service. And so I think it is eventually a question of how far can you get with some of these, your fine-tuned model on GPT-3. I think so far, I'm seeing, and I don't know if you're seeing this, Sinan. I know you spoke with a bunch of companies YC Batch. I'm seeing people build initially on GPT-3, and then as they scale, start to realize that for us to eke out performance, even if we were to fine tune this again, we really need a domain specific model that
Yeah.
we own, and we need to orchestrate that and embed that in our app. And due to latency and issues, we need to really own that because it's such a core piece of the stack.
Yeah, the number one advice I give any of my clients, because I consult on the side still, the number one advice I give all my clients is let's build on GPT-3 or some proprietary version. Let's collect the data that we're using as ethically and safely as we can. Let's collect the inputs and outputs. Did people thumbs up or thumbs down it? Did they alter the output in some way in their final version? Collect all of that for the purposes of either fine-tuning GPT-3 to your point, squeeze water out of a stone, eke out that performance delta, or switch to a open source model, which maybe the thought process is using GPT-3 is too expensive at scale, so we're just going to use it enough to get enough data to fine-tune an open source foundational model to a point where it's just as good as GPT-3 was, but now it's down to cost of hosting, which is negligible in comparison. So a lot of that considered, but none of that's possible without the data, right? To all of our points, none of that's possible unless a company has a data set to look at and say, we can use this for our benefit. So for anyone out there who's building with GPT-3, even if it's a hobby project, start collecting that data. And there's a lot of companies out there that will provide this service. They will help you actually store that data for future fine-tuning use. And a lot of them are in current YC, a lot of them are non-YC, former YC. There's a lot of companies out there that are already providing that service. And if you're not doing so, you should be doing that. Because at worst, you can fine-tune GPT-3 to make it even better. At best, you can train an open source model to be just as good and save a lot of money in the long term.
Got it.
Yeah.
We talked a lot about fine-tuning. It's a good transition Speaking of fine-tuning, Sinan, it might be helpful to chat through RLHF or reinforcement learning with human feedback. But let's talk a little bit about what that is and why it is becoming so important for products leveraging AI. Yeah,
I'll give a quick history lesson. Modern early language models. I'm talking post-transformers. The transformer being the parent architecture, deep learning architecture that kind of started this wave in 2017. Talking, at least for now, post-2017, a language model's job, more or less, is to predict missing words. Like, what is the best word to say next or perhaps in the middle of a sentence? But let's take the simple example of GPT-type models that are thinking one token at a time. They're thinking, what is the next token that makes logical sense given what I've already read? Before January 2022, OpenAI's models were very, for the most part, simply that. Given what I've seen, what you've already typed in, what are the next logical tokens that make sense? Now, sense is and that's kind of the term of the day here. What makes sense to the language models where it used to be just, well, what makes grammatical sense? What would I expect to see given what I've already saw? What makes this document that I'm producing the most cohesive document possible, again, based on what I've read in the past, with no regards for what the human is actually, the user is trying to actually get from the system. It's just, I've read similar things. This is how I would expect this document to be finished written, or how I would expect the next tokens to look. This is post 2017. Now, in early 2022, late 2021, companies like OpenAI being the kind of the key developer in the minds of people in the field of ML, they propose a way of alignment. And now that's kind of the bigger word of the day. Alignment is basically how you make a machine learning's output more in line with a user's intent of using the model in the first place. So I give a lot of examples of this in my lectures and my books. Before and after alignment protocols were, I'm using the term alignment very specifically here, not saying RLHF yet. Before and after alignment is a really key difference. Before alignment, the language models are just spitting out tokens that make sense. Again, grammatically, just what would you expect this to look like, but have no regard for what the human is trying to actually do. After alignment, you expect a language model's output to be more in terms of, well, you were trying to get something from me. Here's what I think you are trying to get from me. And how you do that alignment matters. So the first big example of alignment was RLHF, reinforcement learning from human feedback. There's a whole paper, blah, 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 from OpenAI that talks about the process, which is we take a language model, which GPT-3 was released in 2020, by the way. So years ago, GPT-3 existed, but it didn't really make the waves of news it did. Not until January 2022, when they introduced RLHF alignment into their GPT-3 models. They kind of affectionately called that family Instruct GPT, meaning you are now able to just instruct GPT to do something and it will do the thing that you asked. As opposed to you instruct GPT to do something and GPT thinks it's just reading some blog post. It's like, oh, I'm going to finish this blog post for you. But not intentionally aligned with what it is you asked. Maybe you asked it to translate something and it said, translation is fun. I love translating stuff. It's like, well, no, that's not what I asked. I want you to actually translate this piece of text. And it was very bad at that kind of task until 2022. That's when you saw the news really picking up on this wave of GPT where, you can just ask it to do something and it will do it. That's awesome. I think that kind of shift in alignment is why we are now talking. It's probably why we even started this podcast in the first place. That's what made people want to talk about GPT. It's also what introduces competitors to RLHF, which we'll get to, but it's really all about alignment. How do you make your language model say the thing that the user intended it to say and not just finish my sentence, please, in a fun or whimsical way? That's really the shift that we see in alignment, which is, again, word of the day.
One thing I think that is still a bit confusing to me, Sinan, is how RLHF can be different from legacy annotation tools and how that process actually gets done. So maybe actually you're building a startup in this space. So could you talk through how the sausage gets made in terms of, and how it might be different than just using a scale, for example, to annotate data?
It's not too different. I'm not going to lie to you. Like looking at how the sausage, it's not too different in the sense that RLHF still relies on human labels. Now, the labels are not as simple as hot dog, not hot dog, but the labels are now more given this input, which is an instruction. And I'll talk very strictly in Instruct GPT in the first iteration of RLHF that we were looking at. Given this instruction to the GPT model, here are a few outputs that the model gave. A human then comes in and looks at all the options that the AI has said and says, this is the best one. And then it effectively repeats that process. Okay, this is the best one. Great. I'm going to update the model to be more in line with giving this kind of output. And then it tries it again, and then the same or maybe a different human looks at it with options and says, that's the best one now. And it just keeps doing that until it's more in line with, I see. You want me to answer the question in a concise way, in a non-toxic way, in a whatever way. So again, in a sense, it's not too different than what scale would provide. You're still just getting humans' feedback on reading the output from a machine learning model and saying, this is the best one. It's just slightly different than, given this text, give me the ideal label. So a human is not always writing the best response, although that is kind of part of the RLHF. But a human's job is not just give me the right answer. It's a lot of the times it's look at what the AI said and just tell me the best option it gave. Even if it's not perfect, still give me the best thing it said. And we're going to repeat this process until we are completely satisfied that the option it gave was the best option according to the human. Obviously, I'm simplifying a lot, but again, a lot of it is still a human staring at a screen, picking from a multiple choice list of that's the best one, that's the best one, that's the best one, and sometimes even writing out the best option and saying this is the best option. I know that was so mind-blowing, your camera flew back, right?
It absolutely flew back.
I know, now, obviously, the ecosystem, the reinforcement learning side of it all is its own behemoth, but again, purely talking about a human labeler's job, it's not so different than what it was before. It's just, frankly, clever. It's just frankly a clever way of introducing humans into the system that make the AI more, again, aligned with what a human is trying to do. Biases and all.
I think that's a core area that I've been thinking about is a lot of, we just already talked about defensibility in notes, a lot of ways you can differentiate is having these tight product flywheels. So the way people use your product, you could actually get users to input training data. And so one theory a lot of folks have in AI is that there's a much bigger first mover advantage because you can get that flywheel going and get human feedback and get accurate responses. But the interesting thing is, I'm curious how long this holds. To your point on Instruct GPT, there are actually data sets that are kind of preference models that actually help align existing general models by fine-tuning them on that data and aligning them better with human feedback. And so in some cases, they need human-labeled data, but they may not need manual at every single point, similar to maybe how some people are familiar with it in a computer vision context. So I am curious whether, Sinan, whether it is going to continue to hold this, particularly as these models get better and better and better and more generalizable, how important this continues to be for machine learning engineers in their day-to-day work.
RLHF in particular? Because I think RLHF may not be the right choice. It may not. OpenAI is betting on it correctly. It's providing excellent results. But it's still too early to say it's the right way to go. I would bet OpenAI would admit as much, right? They're seeing great results, but research is always evolving, right? Someone at OpenAI will have another clever idea and try to augment it with some automated process. Like Anthropic's Claude uses RLHF, reinforcement learning from AI feedback, and says, yeah, there's some human feedback, which they admit RLHF does play a part in Anthropic's training of their model, but where they saw deltas and improvement, where, well, once you get the human's feedback, you can then kind of scale that up and get feedback from other AI models to kind of speed up the whole process. So it's not like it's a totally different process. It's just, well, how do they inject some automation to go faster? So I think to the day-to-day developer, like me or whoever's listening, RLHF is not something that I think you need to drop everything and learn, like this is the right way to do it, because frankly, it's hard, and it may not even be the right answer going forward. And I think a lot of the times people can get what they are looking for from just already pre-trained models who may or may not have had RLHF behind the scenes. So I guess TLDR is alignment is the, again, word of the day. RLHF is a very promising approach, not perfect, but promising approach And I think other companies have started to show improvements on it. Again, within the year, other companies are showing improvements on it. So it's something to look at. For all we know, Akshay, in 3 years, reinforcement learning will not be the preferred approach in alignment. For all we know, it seems unlikely, but it's possible. It's possible that we will say, hey, reinforcement learning did a great job, but it's this new thing, this new kind of generative discriminative, who knows, some kind of model will come in and say, hey, this is actually the better way to align language models, and we'll all switch to that. So alignment is here to stay. Reinforcement learning from human feedback may not be the end result, but it's an excellent step in alignment, in my opinion, at least.
What are other approaches to alignment that certainly RLHF is the dominant current paradigm that's getting a lot of attention, but you mentioned previously in our talks constitutional AI. There's different approaches to alignment, but what are a few that you think have a chance of becoming increasingly important if RLHF fades away and becomes a less dominant approach?
Yeah. So speaking of constitutional AI, that's what Anthropic's Claude is really pushing out there, is the idea, and again, it's very similar. It's going to sound eerily similar. The idea is still let the language model attempt to answer a question or hold a conversation in terms of a chat style GPT or similar model. But instead of a human looking at every single response, what if instead we let a third-party language model, the one that is not attempting to be the final model, what if we give it a set of principles or a constitution, rules on how to behave? Very Isaac Asimov, laws of robotics. So what if we taught a language model these rules and said, okay, so the model we want, Claude, says this. Give an instruction or conversation, it said this. Hey, other model, is this in line with this random sampled principle of your constitution? If not, what would you recommend? And then this is where I'm kind of riffing, but the idea is you give a constitution of principles and you try to align the messages based on those principles instead of a human just selecting the best one, which does two things. A, it speeds up the whole process, right? AIs talking to AIs, teaching each other how to act is faster. B, you also have this again, you have the set rules of these are the rules that we are training our models on. So people can, it's a step in transparency and saying, if these are the rules we're trying to align on, you can be sure that we did a lot of work in aligning the LMs, the language models outputs to these principles. The third thing, the third thing it can also do for the ecosystem is provide more data for other people who want to do their own reinforcement learning, right? It provides this gateway into saying, hey, you don't actually need tens or hundreds of thousands of people who are looking at your labeled data. You don't need that necessarily. Maybe you need a few people, and the rest can be done at scale with other language models. And open source tools for RLHF, which exist, can then be scaled up faster, and you can see more competitors in the space, which at the end of the day is good and bad for what it's worth. But I think that's kind of like the main, as of now, the main competitor to RLHF is constitutional. Teach the AI rules. These are the rules that you have to abide by. And if you say something, another AI model will judge you on the rules. And if the other language model thinks you didn't follow the rules, try it again.
Oh man, now I have so many questions about the singularity and
oh god, again,
AI, regulated AI. That's a whole separate podcast series. There's not even a. But
I was about to say, I'm not even the best person to talk about that philosophical approach to AI.
We'll get Nicholas Bostrom or Udowski on the next pod for sure. I think on that note, we might wrap it up and call it for next week. But thank you, everyone, for joining us this time. And we'll look forward to the next one. We have a few different exciting guests and a variety of topics. You can, of course, reach us at our emails, which we'll put in the show notes as well. And looking forward to the next one. Thanks all.
Bye, everyone.